and then we can start. Okay. Okay. Good evening or good afternoon, depending on wherever you're joining from. My name is Simisola Adelusi. Um, I currently work as a senior systems analyst in the financial sector here in Canada. Um, my presentation today is on sequence diagrams, and I'm going to try to make it as interactive as it can be. Um, I don't know if you can raise your hands, but has anyone on this call ever created a sequence diagram, or like have you worked on a sequence diagram before? I don't know if I can see. Okay, I can't really see hands. Is anyone like raising their hands? Because I can't really see because I'm on slideshow, so I can't really see anyone's hands. Oh, no. Okay.
Yes, we are raising our hands.
Okay, sorry, I can't really see because I'm already on the slideshow. Okay, talk about, have you like you have worked with sequence diagrams on a scale of 1 to 10? How what would you say your knowledge about sequence diagram is at?
Let me say six.
That's fair. Okay, fair. A- Any other person has their hands up, you can just turn on your unmute your mic and just give yourself a rating from 1 to 10. Can't really see. Okay. Okay, I guess it's just okay. Okay, let's get right into it. Um, so basically, today we're going to speak about sequence diagram, right? Um, it sounds technical, right? Because before I became a business analyst, when I did CBAP, I used to think sequence diagrams was something that was very pretty technical and was complicated for me. But going into it at work, it's very simple. You just need to understand the logic behind it. So basically, it's a type of unified modeling language, right? It shows how participants in a system interact step by step, right? So, as a business analyst, when you're trying to design a your business requirements for your dev guys, you sometimes a flow diagram might not cut it, right? If it has to do with systems interacting, you will need to create something like this, which is a sequence diagram. So basically, it shows how to understand who is talking to who, or who is talking to what in a system and in what order. It also shows the order. Let's go right. So I might spend some time on this slide because I'm just going to introduce APIs, because I don't think I mentioned it earlier. I work in platform data integration team, and 80% of my work has to do with APIs, which are application programming interface, right? So basically, I'll also explain what APIs are, just so that it doesn't sound so technical. I'll break it down so it's everyone on this call understands what I'm talking about. So sequence diagrams is not just about UML notation, right? It's about using a simple visual technique to understand how systems interact or how systems behave. Um, I'm 100% sure everyone on this call uses WhatsApp, right? I'm just going to use that to describe um, what sequence diagrams are and in what situations we use sequence diagrams. When you send a message on WhatsApp, right, the app processes that message, and the other person might be in a different continent, gets that message immediately. So that whole process, I pick up my phone, I type hello, and then the other person receives it. That's a sequence, right? So there are various systems that interact back end for the other person to get that message. So basically, all this is just layman's language of what a sequence is. So sequence diagrams are helpful when requirements involve multiple systems, right? And when you are integrating systems together. So integrating means you want two or more systems to interact with themselves using APIs. I will get to that. So I'll get to what APIs. So it's useful for API designs, for integrations, and for testing. I'll get to explain what that is, so it's easy for everyone to understand. So it also helps teams agree on behavior before building a solution, right? So what is an API? It's just a way for two systems to talk to each other. I mentioned WhatsApp, right? I could also say when you use your banking application, you input your username, your password, and then you log in, or there's an authentication pop-up that comes up, right? And then when you're authenticated, that moves you into the banking online banking platform. All that process from where you inputted your username, login, to getting access to the banking system happens because an API is calling an endpoint, right? And then it pulls your details from the backend system, which is like a database, and it sends a response back to the front end. Sorry, I'm speaking technical language, but I would explain further as we go into this discussion, this study group session. Now, so I'm going to use something that we are all familiar with. You go to a restaurant, right? You go to a fancy restaurant to order food. Think of an API like a waiter in a restaurant. I'm using APIs here again because APIs are like the best way to describe how sequence diagrams work and in what situation you need sequence diagrams, because it's basically you're showing how backend systems interact, and they interact using APIs, right? So think of an API like a waiter in a restaurant. So I am the customer, that's equivalent to a user. And then the waiter is the API. And then the kitchen is the database, right? So the waiter goes into the kitchen to get, let's say you want jollof rice, goes into the kitchen to get jollof rice and brings it back to you, the user, which is the customer. Now, take for example, I walk into the restaurant, I place an order. That's the waiter is the person that takes my order. Now, the waiter is the API. In the technical scenario, the waiter is the API. So the API gets your message, has a user from the front end, and takes this message to the back end. That's the kitchen. So the waiter goes to the kitchen. Oh, there's a customer out there. She wants jollof rice and chicken and salad. So the kitchen in this case is the database that holds millions of information. It could be your core banking system, it could be your inventory system, it could be any back-end system that holds all the information. So basically the API is the waiter. It goes back end, gets that message and returns it back to the front end, and it shows it gives you your food, or the waiter gives you your food. That's the API gives you your response after sending a request through it to the database. I don't know if that makes sense. Sorry, because I'm in presentation mode, I can't see if your hands are raised, but we'll take questions after this. Okay, so sorry. Moving on. I hope that analogy is self-explanatory. So basically, the waiter doesn't cook in this scenario. It just passes message. So that is what an API does. The API doesn't process anything. It's just a waiter, a sender. It passes the message from the front end user to the back end database. So next, still on this slide, why APIs are perfect for sequence diagrams is because sequence diagrams are best explained using APIs, because APIs are literally built on sending and receiving messages in order, right? So the API receives the request, like the waiter, it processes it, it calls another system, the back end system, it gets a response and sends the result back to the front end system. So that is what this diagram here is all about. So in later slides, we'll describe what these boxes are, what this arrow means, and what this dashed vertical line refers to when it comes to sequence diagrams. So the user, obviously like the customer, walks to the waiter, sends a request to the waiter here, who is the API, and then the waiter goes into the kitchen, which is the database. So it queries the database, it gets a response, and the result goes back to the API. The API, who is the waiter, carries this response, so it carries this result from the database and has a response to the user in the front end. So that's just an overall summary of what APIs are and how they work, and why sequence diagrams are perfect to describe how systems interact using APIs. Now, everything I'm saying here is based on the Babok guide, but I just created my slide for the sake of this presentation. But everything here is in the Babok guide under the technique sequence diagrams. So bringing it to real life scenario, like when you have a project, right? Requirements are written in paragraphs, right? You have to write your business requirements when you speak to the business team, and people imagine different flows in their head. This was before, let's say, before sequence diagrams, right? And then there are hidden assumptions when it comes to systems design, and when you want to move from just being a process kind of BA to a more technical BA, where you're creating design documents or solution design documents, you have to go deeper into systems and understand how systems interact with each other. So you can't just stay on this or in this box, in this before box, right? So we move to during. That's when you're using sequence diagrams, right? So you list the participants. In the previous slide, we saw like there are 3 participants on how the system interacts. Going back to our example of going into a restaurant, ordering food, the participants in that case would be me, the customer, then the waiter, and then the kitchen. Those are the 3 participants for that particular scenario. Now, also the messages are ordered. You can see that in that diagram, it showed how the messages were ordered. Okay, request food from, send a request to, or call the waiter. So you're calling the API, call the waiter. Then you tell the waiter, go to the kitchen and get me jollof rice, right? So the messages are ordered. So when you're creating a sequence diagram, you have to, create the messages in an ordered manner, so that the developer guys or the people that are going to build the system back end can clearly see what or how the systems are going to interact. So system responses are clarified. That's during, when you're using a sequence diagram. Now, after, when you have built a sequence diagram, this just shows the advantage of using it for your requirements. Your developers know the flow. Testers know what to validate. If you work with QA team, this is going to be so helpful to them. Now they know what response a system or the database will get from the API. They know what format. Obviously, the diagram that I showed before is just a basic sequence diagram. If you want to go technical, you obviously probably add things like other systems that feed into these different participants, right? And what do I call it? What they do, right? If the API validates a user, it's going to have you get a process box that shows that this is a validation call and all that. That's all technical anyways, but I'm just going to do basic here. So the business also sees the expected behavior. So you can also present this to the business users, right? Obviously, you're not going to put so much technical information there, but you just present it to them. Maybe it's the operations team or it's HR. Like, okay, this is how this is how we want to build the solution, and this is how this system would interact. And it can also help you see loopholes in these systems. I'm going to give you a practical example. I think it's like in slide 8 or 9 about something that I experienced on my job. And I mean, sequence diagrams was helpful to pick out that particular issue for that particular project. So basically, a requirement may say system validates the member, but it may not say which system validates, when it validates, what data it uses, or what happens if validation fails. So I mean, all these questions can be answered using sequence diagram. So let's go to the next slide. So now it's one thing to create this diagram, and it's another thing to understand how to use it, right? Sometimes on the job, it might not even be you as a BA that would create a sequence diagram. You might be on a new project and a particular team, maybe the developer creates their own sequence diagrams, and it's left to you to understand what it's saying, how the systems interact, for you to probably build some other process for another project. So it's very important to know how to read a sequence diagram. Now, basically, first of all, you identify the participants. We've spoken about this in previous slides. So participant A, participant B, participant C, right? They're all in activation boxes. We're going to speak about this, I think, in the next slide. These are called activation boxes. Then this is the message. Then this is the lifeline. So yeah, this is the lifeline. Like, this is the message making a call. And then the activation boxes shows if it's going to be a validation or a processing. We'll get right into that in next slides. But this is a lifeline. So these are the participants: participant A, B, and C. So sequence diagrams are read from the top to the bottom, right? So the top to the bottom shows what happens over time. That's why this arrow says time. So the participants obviously are arranged from left to right, but that does not mean that it literally moves from left to the right. The actual timing of how events happen is from top to bottom, but how you read the participants, they are placed from left to right. I will explain further. Sorry, how is this? Sorry. Yeah, just move. So basically, now if you look from left to right, it identifies who is talking. In our scenario of going to the restaurant, if I was going to put that in a sequence diagram, the customer will be here, the waiter will be, the customer will be participant A, the waiter will be participant B, and the kitchen will be participant C. So we're looking at it from left to right. It shows obviously who is talking, who is doing what. Now, top to down means when did it happen. That's this arrow going from top to down shows when did it happen, right? Take for example, in the morning I go to the office and I have to have breakfast, right? So I go to the restaurant, I place an order with the waiter, and the waiter goes into the kitchen and gets my order. So that happens in the morning. In the afternoon, I go to the same restaurant, I order for pasta, and the same waiter or like another waiter takes my order, and then they go into the kitchen and then they bring back my order. In the evening, before I go home, I have dinner, and then it happens like so. Basically, you're reading it from top to down. That it shows over time, but so it's left to right, top to down. We'll do a practical example because to show how that happens, let's go further. So basically, the the customer, the waiter, and the kitchen. It shows the conversation from left to right, and then how it happens over time. So that's showing it vertically. So you start at the message first. The message is the request, which is number 1. And then, so participant A makes a request to participant B. And then participant B calls participant C. And then participant C sends a result to participant B. And then participant B sends the response back to participant A. So basically, you start at the message first, then you follow the arrow downwards. Then you notice the responses and exceptions. Yeah, so the results and the responses. Let me go to the next slide, slide 4. Sorry. Again, I can't see if anyone's hands are raised, but I will definitely take questions at the end of my presentation. So maybe if you have a question, you can write it down. Thank you. Let's go to the next slide. So, yeah, Lifeline. So the Lifeline shows who participates in the interaction. So it's basically the participant in an interaction, and the vertical line shows that it exists through the scenario. That's this vertical line. So the participant can be a user, it can be a system, it could be an API, it could be a database, it could be a service or an external partner. We've spoken about this in previous slides. The dashed vertical line shows the participant's presence over time. So you start by identifying lifelines before drawing messages. I think that's a common sense. You first identify the lifelines before you start drawing the message, like who makes a request or who sends a response and all that. And also in real life scenarios, I'll just backtrack to, let's say, work. The participants could be a user, right? Probably your online banking front end. And then the next participant could be your API gateway, where the API endpoints are stored, and then calls go out and come in through the gateway. Then your core banking system too. That's what I put. Sorry, it's called core API. Probably that's the API or the name for the APIs that have to do with your core banking system. Then Salesforce, probably your customer relationship like management system, could be Salesforce, could be ServiceNow, anything. All those systems and how they interact with each other are the participants. So basically, you will not obviously include every system in your company when you are drawing a sequence diagram. You just include only the systems that send, receive, or process messages in this scenario. I think towards the end of the this presentation, we're going to probably have a small exercise where we'll create something that has to do with login, a user login. So the next slide is the activation box. It's also called execution occurrence. It's drawn as a narrow rectangle on a lifeline. It's useful when you want to show processing, validation, or waiting time. So that's this. So take, for example, you are trying to create a sequence diagram for a user that is logging in, right? Before you log in, or when you're logging into your online banking platform, you have to be authenticated. There is no way you will log in without being authenticated. Probably it could be a two-factor authentication, and then it has to know who is signing in and all that. So basically, in that scenario, you can create an activation box that, because this user is calling this particular API service, it's probably calling an authenticator API service, right? So you can create an activation box there and say authentication, or sorry, validate, right? It's trying to validate who that person is before signing the person into the online banking platform. So basically, this narrow rectangle box on a lifeline is an activation box. So it could be validate, it could be process. So this is just an example of what it looks like. So it explains that the participant is actively doing something, right? The participant in a process interaction. It just shows that it's doing something. It could be validating, it could be processing, it could be authenticating. So in a real life scenario also, API validates an API. It could validate a request, it could check for permissions, it could transform a payload, it can query a database, it can apply business rules, right? An API you can create an API to do all these things. So you can also use an activation box to just show that this is what it's doing, like this is what it's actively doing. So I mean, they are helpful, but they're optional. But for a simple diagram, if you are creating a simple sequence diagram, you can omit them really. But if it's a more technical, detailed diagram, you can include them. I mean, it just makes sense to include them. They show where the processing occurs. So each activation box, if you create a sequence diagram that has this box, each of these boxes can become a test focus area. So when your developers have finished probably creating the solution, maybe the part of the artifacts that they used was your sequence diagram. QA now knows that, okay, this participant is validating, is processing. So it also helps QA when they are testing as well. So these things I'm mentioning are also part of the advantages or the usefulness of using a sequence diagram. Next slide. So then there is messages, right? So a message is shown as an arrow. Arrow direction shows who initiates the interaction. Message labels should be action oriented and clear. I mean, not everybody when designing their diagram includes messages, but then it won't make sense. You have to include your messages. Now take for example this. So there's the front end participant, and then there's the API. So front end being the user. So front end, I believe like everyone knows what the front end is. That's the screen. That's the UI. What you, the user, what you are interacting with, right? So from the front end user, you submit a request. So obviously that's the message to the API. And then the API sends a return response. So the arrow is the other way around, back to the front end. Take for example, let me see, I want to check my account balance. I've signed into my online banking platform, but I want to check my account balance, right? So the front end, the UI is my banking app. So when I click check account balance, so that clicking it makes a call, an API call. I mean, like technical language, we call it API call. It makes an API call to the database, right? And then the database checks using your name or probably some other criteria, checks your account balance in the core banking system, and then it sends a response back to the API that Simi's account balance is 30,000 naira, and then the API takes this response in a particular format. It could be JSON, it could be XML. It sends this response, but in a format that obviously the front end system can interpret it to the user, and then it returns this response back to the front end system. That's the return response. So yeah, that's that message. And then in a case where you want to publish an event, sorry, I think I would ignore this publish event because that's some other complex term. Anyways, but that's the basic understanding of it, right? So the messages just shows, like obviously labels, like you're labeling a diagram. It's just a label to show what's happening. So front end, you submit request, and then the API returns a response back to the front end. So messages are verbs of the sequence diagram. It could be retrieve quote, return response, validate member, and all that fun stuff. Sorry, right, so obviously, like I had mentioned earlier, a good message label makes the diagram useful. Avoid vague labels when you're labeling your sequence diagram. So I think that's basically about the slide. Messages are pretty self-explanatory because as a BA, one of the it's not only sequence diagrams that you might have to create. Like you might also have to create flow diagrams, probably like using Visio. And if you create flow charts diagrams, you know that you always have to label your arrows, and that's the same logic that applies here. So let's go to the next slide. So common message types. So here's where it gets technical in real life, but it's not technical. I'll try to break it down. So there are different types of calls when it comes to how systems interact. So I feel like this is it's an architectural kind of understanding. So when you understand what these calls are, it's basically makes you, you are getting to like a technical BA kind of level, right? So there's synchronous call and asynchronous call. I think, sorry, this just came to my head because I studied what I studied in school had to do with biology. I studied plant biology, right? And I remember in science class there's sexual and asexual. I think how some particular living things recreate themselves. Sorry, I might not use the right words, but I know asexual is when they have to do it on their own. They don't wait for anybody or any external organism to help them. Then obviously sexual, they need another external organism to help them procreate. So that whole idea, just applies to this as well. So synchronous means the caller waits for a response before it continues. Asynchronous means the caller doesn't wait for a response. It just continues after sending a message. I will still link this back to our waiter and restaurant scenario. So sorry. An asynchronous call can also be fire and continue, right? So an API makes a call to a database or it just sends a message. It doesn't wait for the database to send a response back. It just sends a message and just continues doing other stuff, right? It doesn't wait for a response. That's asynchronous. But synchronous, which is what we've been discussing since, is probably when the API sends a message to the database and then it waits for a response. Like, did you find this user's details in the banking system? Yes, it sends that detail, right? So it has to get the response for it to continue. So that's synchronous. So basically all this has to do with timing and frequency of communication. So synchronous means a client or an API or a participant sends a request to the server and it waits for the response before issuing another request. I think I call it in integration, we call it it's like request and reply. It's a type of integration pattern. It's called remote process invocation, request and reply. So it waits for a response before continuing. um Asynchronous like communication means the system doesn't wait for the reply before proceeding. So basically, the application sends a message and the system returns a reply as soon as the resources are available, right? So the system just sends a message and just goes away. Like, if like, you can send the response when you have what it takes to respond back to me, but I'm still going to continue and do other stuff. Now let's go back to our scenario of this restaurant. So imagine, so now let's speak about synchronous messages or synchronous calls. So imagine I'm at this restaurant again, and I'm the user, and obviously our API is the waiter, and the backend system or the database is the kitchen. So I asked the waiter, can you, so I let me just paint the picture in my head. So can you ask the kitchen if they have jollof rice? I want jollof rice. Now the waiter goes to the kitchen, and I wait for the answer before continuing my order. I want to know there and then if there's jollof rice, so that if there's no jollof rice, I will walk out and probably go to the next restaurant close to me that has jollof rice. So basically, I ask the waiter, go and ask the kitchen if they have jollof rice, and I wait for the response, the waiter to get back to me before I continue my order. Or maybe if they don't have jollof rice, maybe I'll now maybe order something else, beans or something, right? But I need a response. So that is synchronous communication, because the sender waits for a response before continuing. Sorry, I just tried to explain it in terms that we are used to, so it's actually very easy, because in real life it can be very confusing. Now let's use that same example, right? I tell the waiter, please tell the kitchen. I walk into a restaurant, probably same like the same restaurant. I tell the waiter to please tell the kitchen I would like, maybe I ordered fries and ketchup, and the ketchup was so small. Like restaurants these days, they will just give you one very tiny ketchup with a truckload of fries, and I'm meant to use that tiny ketchup to eat that truckload of fries. Like, please give me more ketchup. Like, why are you using ketchup, right? So I tell the waiter to please tell the kitchen I would like extra ketchup whenever it's ready. Now the waiter, delivers the message, but I continue eating and talking with my friend without waiting for the confirmation. All I did was tell the waiter to please tell the kitchen that when they have ketchup, they should send it outside. So I sent it on a message. I sent the waiter, on a message. Or I sent the API to just send a message to a system. I'm not waiting for a response. I'm still going to go ahead and I have the fries already. I have no choice but to eat the fries, right? I've already paid for it, but I just need extra ketchup. So if they have it, or when they have it, they should, send it to my table. So that's what an asynchronous communication is. So the waiter has delivered the message. So you're basically sending a participant or an API to send a message, but I still continue without waiting for a response. So that's basically what an asynchronous message is. So there is return, response, and particular. So yeah, it's just those two that is in Babok: synchronous call and asynchronous call. And I hope that with how I've explained it, you understand it better. Let's move to the next slide. So this is basically what we've been saying since. So these are the participants, the user, the front end system, API, the database, right? So the user submits a request to the front end, right? And then the front end system makes an API call. Sorry, the front end system makes an API call. It calls the API, so that's why there's an API call on the message. And then that call queries the database. So that's why there's query here. Now the database has the results. It sends it to the API, who is our waiter, and the waiter, sends the response to the front end system. And obviously, what does the front end do? It displays the result to you, the user. So that's basically how the diagram works. It's a very simple diagram. In fact, I prefer it to a swim lane diagram or a flowchart because it's very straightforward. But then when it gets really technical, it's not always nice to look at, but it's pretty straightforward. So basically, you are describing how systems interact. Yeah. So let me see, next slide. So I had mentioned earlier that I was going to discuss about a real life scenario or something that I have worked with on my job, just so that it also helps you guys understand sequence diagrams and how it works. So there was this project I worked on last year. It was a payout codes generation. So basically the dealers, so there are dealers, right? So dealers are people that handle auto financing, right? If you want to get a car and you walk into a dealer and then you tell them, oh, I don't have money, this car is worth $50,000, but I don't have money, I need a credit. So the dealer can arrange the loan with the bank, and then give you the car, but the bank does all the back end process and all that. So this was for payout code generation. What is a payout code? So a payout code basically is is a code. So a payout code is something that shows how much a customer is owing, right, with their auto finance loan. So basically, it's the system calculates their outstanding loan amount, every interest, fees, per diem, or basically any other interest or fees that they need to pay off before they pay off that loan. So the system calculates all that and sends it to the dealers. So basically, we wanted to automate this payout codes generation because currently, if a dealer needs to know what a particular person, now obviously for this person to have a payout code generated, they have to have an account with the bank, right? So obviously these are people that probably have an account with the bank. So sometimes they want to refinance their auto loan. So the dealers need to know how much they are owing. So they call it payout code. So they want to be able to log into an application or a portal. Then when they click on generate payout codes, the system back end automatically gets the amount that this person is owing and displays it on their system. So instantly they tell the customer, oh, you're owing probably your loan is probably left at $2,000. So you need to pay this in the bank before we refinance your auto loan or before we issue you another auto loan for a new fancy 2026 model of Tesla or stuff like that. So basically, so that's why, so the first participant here is the dealer, then there's the API gateway, and then there's the core banking system API, which is called the core API. So the core API basically retrieves, sends response from and to the core banking system. Now, for a dealer to generate a payout code, they need the VIN. So if you know what a VIN is, I think that's the vehicle identification number. So it's, I mean, ideally it should be unique for cars, right? But while I was I was looking at our database, I realized that VIN was not unique for cars in our database. So VIN would not have been the ideal search criteria for this, right? And then also drawing the sequence diagram, the participants also got me asking, what if there is a situation where the dealer inputs the VIN and then the backend system generates 3 VINs? So how would they know that we are not giving another customer's payout code to a different customer? So there are issues involved. That's a compliance issue. That's an integrity issue. Banks are highly regulated. You cannot just generate a code for another customer's VIN based on the fact that they have the same VIN. You get that? Those were loopholes that I identified, right? So I went to our database SQL, saw and ran some queries and saw that VIN was not a unique search criteria. Drew the sequence diagram and then saw that, okay, if the core API is going to call VIN from the core banking system, what if it generates more than one VIN that belongs to different customers, and there's the risk of giving the payout code to the wrong person? So basically, when you identify all the systems that are interacting in a process and what they do, this can also help your requirements analysis and also help you pinpoint problems ahead of a project, just so that, as you're building the solution, it helps you identify these problems. So the outputs, obviously, from drawing or creating a sequence diagram is you have clear requirements, you have more insights into error handling, and it also helps you in creating your test cases for QA team, right? So basically, so this sequence diagram, we can just go through it together. So the dealer requests a payout code from the API gateway. Now the gateway does some validation. So this validation will probably show that, okay, this VIN must match. Maybe we should include a second level search criteria. So if the banking system sends a response of 2 or 3 VINs, we can now streamline it using their unique account numbers, right, to know which particular customer has this payout code. And no, we could not use names. Names would be terrible, because in this part of the world, one person can have about 10 people can share the same name. So obviously it has to be VIN or account number, or just using those two. So basically, the core API retrieves the payout code, and then it sends the code data to core API. Then the core API formats the response. Obviously, I think that's one of the usefulness of using an API gateway. It formats the response it gets from the database to a response that the front end system can interpret and display to the user. So it returns the codes and error from the gateway to the dealer. So that's basically what that project was all about. I think I'm almost out of time, but I hope that this scenario, which is a real life scenario, would also deepen your understanding of how sequence diagram works. So I think to the final slide, so basically the key summary here is, obviously, the sequence diagram shows who talks to who and in what order. So it's best for APIs, it's best for integrations, workflows, right? Um, because it shows how these systems interact with themselves or with a user. So yeah, I put something here. Yeah, keep it simple, right? One scenario per diagram. I mean, if you're a real pro, or if you think that your audience are pros in reading sequence diagrams, then you can maybe decide to put like one more than one scenario in a diagram. Um, so let me see, because I might have to stop sharing my screen. Um, so let me just stop sharing for a while. I'll still share. Sorry. Um, so I wanted to ask, so I can see people that have their hands raised. Sorry, I'm just. So during a login flow, or if you want to design a login flow, let's say for an app or for anything, can anyone either probably raise their hand or put it in the chat, tell us who the participants would be for if you want to create or design a login flow. Sorry, let me see. Okay, the chat's here. Okay. So this is me throwing out a question. So if you can unmute your mic and just let us know if you are to design a login flow, just tell us who the participants or what the participants would be to log in into a system. Yeah.
Yeah, hello, good evening.
Yes. Hi. Good evening. Yeah. Okay. Yeah.
Yeah.
I'm seeing some hands. Yeah. Go ahead.
Okay. So I think we have the user, right? Then we have the system.
Okay. Yes. Yes.
Then we have the DB. Because
Database.
I
Yeah.
think, yeah, because we have the DB to validate if there is a details account has been created to validate
Yeah.
login.
100%. Yeah. 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 That's correct. Thank you, John. I see your hand is up. John. John.
Yeah, I just spoke. I'm the one that just spoke now.
Oh, okay. 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 Yeah. Anyone else? I'm just going through. See. Anyone else? But yeah, that's totally correct. So the okay, yeah, someone posted here in the chat the user, the front end API. Nice, nice. Yeah, those are participants. Sorry, let me just go here. So I would say for a login system, let's just walk through it, right? I want to log into. Let me. Sorry, it's just because I've been in the banking sector all my life, so it's just bank apps that I have in my head. Um, so I want to log into the online banking platform. So yeah, the user, right? Me, I am a participant. The banking application, like John said, the system is also that's a participant. And then when you log in, you get a pop-up maybe to input your token or to authenticate yourself. Maybe it sends a message to your phone. So there's also the authentication system, SSO or whatever. So that is also a participant, right? And then I get into the application, and then I can now decide to do a transfer, right? And for that transfer to happen, the API or the has to make a call to the bank's banking system. So the database, like John mentioned, is also a participant. So like those are participants for a login flow, right? and then you can now design how calls are made and all that fun stuff. Does anyone have any question? I've been talking too much. It's time for you guys to talk. Does anyone have any question?
Good
Does anyone
evening.
have any
Yeah,
question?
let me ask. Thanks so much for this section.
Sorry,
So I
Paul.
wanted, can you hear me?
Yeah, I can
I
hear you
said
now.
thank you for
Yes.
the section. Okay, so my question is it possible to prompt AI to generate this thing out for us, right? And
Yes.
what is the should I say software that is very simple to use? I think I've heard of Draw.io
IO, yeah.
and no, but yeah, which other tools that are actually
Yeah.
easy? I think I've used Miro or Miro or something too.
Yeah.
Which other tools that can actually help in doing
Yeah,
this?
I mean you've mentioned the main ones really. So the good thing about AI is that most of these applications have their inbuilt AI, right? And even if your organization is actually very strict, your these applications have their inbuilt AI. So there's Visio, right? So you can do this on Visio, and Visio has its own AI agent. I Part of the things I wanted to actually do was actually to show you guys a real life drawing using Miro and Draw.io, right? So I can also demonstrate how you can use AI to generate a login flow in like 2 minutes. It will create the sequence diagram, how the calls are made to the front end, to the back end system, and then you can now decide to probably edit it and all. But all these apps have their internal inbuilt AI. So there's Visio, there's Draw.io, there's Miro. Then there's something called I've never used it before though, but it's something I would actually explore after this discussion. It's called it's Platinum UML. I think sorry, let me just get the exact name. Sorry, I'm trying to get the exact name. So sequence diagram is a type of unified modeling language. So there's an app for sequence diagram. It's called. Sorry, I'm just trying to bring that up. I've never used it before, but I think I would actually want to explore that. Uh, okay, sorry, I was in the wrong thing. So yeah, so is plant UML, plant UML, yeah, plant UML. It's a server that is built for sequence diagrams. So you can literally put in something like a code, not a code sha, but if you understand how it works, like SQL, you can input a query into it, and then it will generate a detailed, when I say detailed, diagram for you. Like very detailed. Yeah, let me write it, let me just drop it in the chat here. So it's called Plant UML. So you can also explore it as well. Any other question? Plant UML. Anyone else have any other question?
Okay, Simi, my own is not really a question. Can you hear me?
Yeah, sure, I can hear you clearly.
Because I just wanted to react to what Paul said. So, Paul, it's good to use AI. It can actually make your work very fast. But what Simi is teaching is very instructive. Instructive in the sense that you need to understand the basics because there's always a caveat and a clause to AI prompts to say that this is subject to error. So, even when you are using AI to make the job faster and easier, you need to understand the drawing or UML drawing proper because there might be
Yeah.
mistakes
Yeah.
on the drawing. So with your knowledge, you can now make a few corrections and use it. But you most times, often than not, from experience, I see a few adjustments you have to make before you use it. So if you don't know these basics, you won't be able to make those corrections. Be able to use what AI is giving you.
100%.
Thank you.
Thank you so much for that. 100%. I totally agree. Aside this, I mean, AI is just like, maybe it just gives you a template, right? So I think that's where he was coming from. It just gives you a template, and then you can build on that, because you find yourself in situations where you have to defend your drawing, not defend, but like you have to present to stakeholders. You have to present in some cases to directors. So you have to know what you're saying. Like, okay, this system is going to interact with this system, and then we are seeing some issues. It's going to validate this and all that, and then yeah, adding something that doesn't even make sense or doesn't add any context. It's going to be obvious that it's AI, right? And you're going to shoot yourself in the leg. So obviously, AI can give you a template, good, fair enough, but you also have to also do your own understanding, speak to the technical guys. Okay, so what response or what system is sending a response back to this particular API, or is the API going to wait for a response? Is that going to be a synchronous or asynchronous call? And because sometimes like you have to include this in the sequence diagram for the developer in your team that will build that solution. That's if I mean, different teams have their own dev team. But yeah, that actually makes sense. Any other question before I just show you guys something?
Hi, hello, sir.
Hi.
Thank you for the insightful session. I have a question. Okay, I mean, as a BA, you know when to, okay, you're working on a BRD, for example, and maybe you need to insert a flow diagram in your BRD. Can you hear me?
Yeah, I can hear you.
Okay. So now, how do you determine when to use a flow diagram and a sequence diagram? So can you just throw more light on it? Thank you.
That's a good question. That's a very, very, very good question. I mean, so I would say, in my opinion, I would use a flow chart if I'm trying to describe processes, right? If I'm trying to lay out processes, nothing technical, maybe okay. The operations. I'm just trying to look for a particular real life scenario. Okay, maybe I want to design a process of how a bot is going to integrate with, or let me say, our loan original system is going to integrate with our CRM system, Salesforce, right? So there's the process of how I want to design a process of how the bot would, move through the loan system, you get, and then get data from the loan system, and then move this data to the core banking system, then move through like different screens. Okay, move through the login screen, then the next screen, and then the next screen. No, it's just two systems, right? Just the loan system and maybe the core banking system, just two systems. And I'm trying to show processes. In that case, I can use a swimlane diagram or a flow chart, right? I'm just showing processes and how, probably you should even swimlane, like I use like 3 systems, 4 systems, how information moves through these systems. But if I want to show back end, a more technical diagram of how systems interact and how they send requests and response to each other. If it's going to be very technical, maybe for a solution design document or for a functional requirement document, where I want to show maybe more than how 3 or 4 systems back end are going to interact, not necessarily process right now, how they're going to interact and send a response to each other, then I'll use a sequence diagram, right? If I want to show how back-end systems are interacting, but like if it's just processes, front end, how the processes are moving, and I also feel that for processes there might be no need to get a response or make a call and all that, right? processes are, they just go with the flow, right? But in a case where a system needs to give a response back for a particular system to go ahead to continue processing something, right? Probably two or three or four systems. Then in that case, I would use a sequence diagram. I don't know if that makes sense. Who has that question?
Yes.
Pablo?
Yes. 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 Thank you.
Okay.
Yeah.
Sorry. I think I saw someone's hand.
I
I'm
think that
sorry.
was my hand. I think it was my hand.
Okay. Okay.
Yeah.
Anyone else have any questions? Sorry, do we still have time? Because the timer is, I think we started 1:30 to, okay, yeah, we have few minutes. Okay, so let me just share my screen just to show uh so someone had asked, can you see my screen? So someone had asked, okay, I mean, what app? So I did this like using Miro, right? So good thing, Miro has its inbuilt AI agent. So I just tell Miro, okay, I'm trying to create a sequence diagram to build a login page. Show the different participants. Make sure you include an authentication API because my company uses that, and make sure you show how how the API calls are made. Include the messages that each participant sends to the other participant. And Miro builds this for me, right? I can even copy and paste this, and I can export this as PDF and import it into Visio and then use it as my template, right? So I had done this earlier. So look at, this is the user, the login page, the authentication API, the database, and then a dashboard. Let's say that like you want it to be displayed on a dashboard. So that's for Miro. Now, for Draw.io, I don't know if it has its own inbuilt AI, but I mean, this is just basic. Like this is just you can just do it manually. I did this manually. So basically, if you go to your left, sorry, why is it not clicking? If I click on activation box, for some reason it's not. Okay, that's weird. Maybe I need to refresh. So if you just search for the names of the diagrams, like activation box, it will bring it out. Search for lifeline, it will bring it out. Search for message, it will bring it out. So if I search for activation, why is it not? Okay, there's something wrong here. I don't know why it's
You are
freezing.
not clicking on the search icon.
Sorry? No, I had even. No, if I just. Oh, sorry, I was clicking on the wrong thing. So if I click here, thank you so much. So if I click on Lifeline, search. Yes, thank you. So if I click on Lifeline search, so yeah, these are sample Lifeline that I could use. I just drag it here, right? So Lifeline, I can put the participant A here, participant B here, edit that. Then activation box, see if I search for that. So yeah, I can change this to validate, process, authenticate, and then I can also move this arrow. Sorry, I should put this back. So I can move this whole thing. So I can move it here, and then edit it, move it here. So let's just take the whole thing. So move it here. So basically move it between lifelines and activation boxes. So then if I want to generate an actor, so I think that's still under Lifeline. Sorry. So under Lifeline, you would see this guy, an actor Lifeline. So you can click on it or drag it to the left, and then you put your arrow. So this Lifeline is probably sending a, sorry, it looks missing here, but let me just move this here. I could put this lifeline is sending, let's say, a request message to this guy. So let's just take this away, to this guy, right? And then probably what it does here, you can label this as processing or validating or all that. So that's basically how it works. So yeah, draw IO2 might be a good option as well if you don't want to go the AI way to create one. But yeah, draw IO2 can be a good option. I don't use draw IO. I use Visio and Miro. I don't use draw IO. So that's why it's kind of foreign to me. But yeah, I use like Visio and Miro at work. So yeah, sorry. Sorry, so I stop sharing. So yeah, that's basically everything. So yeah, I guess we are done here. Thank you everyone for doing a walkthrough landing page. Mimi, can you explain what you mean by a walkthrough landing page? It's not clear to me. Can you just unmute your mic? Mimi, hope I pronounce your name properly.
Yeah, you do. Can you hear me?
Yes.
Okay, so no, you were saying that
Yeah.
sometimes it's not just about prompting AI to get a diagram, right? So you need to sometimes walk stakeholders through. No, I think you were trying to explain that that scenario. So I was just kind of
Okay,
like giving you, do a walkthrough with stakeholders.
Yeah, okay.
So, and when you were trying to explain when you should use a UML or activity diagram, I was just like trying to give you a word, like maybe like a like you
landing
said,
page.
something not technical. So
okay. Yeah. Thank you so much. Yeah, thank you. You. That's helpful. Thank you everyone. I think our time is up here. Thank you for listening, and thank you to IB Nigeria for giving me the opportunity to share my knowledge. So,
all right, thank you so much. Hello, can you hear me?
Yes, Tope, can hear you.
All right, thank you so much. You've really done well. The session was highly impactful, and I'm sure everybody has gained a whole lot. Thank you, Simi. So we look forward to another section next week. Thank you all for participating as well. Bye for now. Bye, everyone.
All right, bye. Thank you very much. Thanks to the facilitator as well.
Thank you so much,
Thank you.
Thanks.
Bye.
Bye.
Thanks.
Thank you.